High-impact jumping sends a shockwave through your ankles, knees, and lower back. Controlled biomechanics target your cardiovascular system, bypassing destructive joint friction entirely. This approach relies on a strictly enforced zero-impact protocol designed to maximize fat loss without the typical degradation of knee or lumbar cartilage. To begin, clear a 6x6 space. Work in bare feet or flat-soled shoes, near a reflective surface, to self-audit your joint tracking. We will achieve this intensity by eliminating momentum. Every exercise we cover requires a mandatory 3-second eccentric downward tempo. This shift in focus means that metabolic conditioning is driven by muscular time under tension rather than the height of a vertical jump. We start with the slow-motion squat to reach, which serves as the mechanical substitute for a standard plyometric jump squat. During the initial descent, shift your body's center of mass backward. Your hips should drop as your weight settles firmly into your heels. Maintain a strict 3-second internal countdown on the way down. This prevents you from relying on gravity and forces the muscles to control the entire eccentric phase. Lower yourself until your hips reach the depth threshold, stopping when they are parallel with your knees. From the bottom, drive kinetic energy through the heels to stand, finishing in a full calf extension while keeping your toes anchored to the floor. This animation shows the distribution of weight. The downward force vectors transfer safely backward from the knees into the heels and glutes, shielding the joint from the vertical load. As you rise, the energy travels from the heels through a straight spine and out through the hands at the peak of the calf raise. This full body extension maintains high heart rate demand by engaging multiple muscle groups simultaneously. Sustaining the calf raise at the apex preserves that cardiovascular load while neutralizing the shear forces that typically stress the knee ligaments during a jump. To replace the ballistic burpee, we utilize the step-back plank, focusing on core stabilization rather than explosive ground transitions. Bend deeply at the knees to plant your palms flush on the floor. It is vital to keep your upper back flat rather than rounding the spine to reach the ground. Step back with one leg, pause, and then follow with the other. This deliberate sequential motion is mandatory to avoid the jarring impact of a backward jump. The most common failure in this movement is lumbar sac, a collapse of the lower back caused by disengaged abdominal muscles. Proper geometric alignment requires a horizontal, rigid line connecting the shoulder axis directly to the hip joint throughout the transition. If the core disengages, this structural collapse occurs, placing significant mechanical stress on the lumbar spine. Forcing your body to move through these steps sequentially requires continuous core tension. By removing the bounce of a jump, you maintain a higher level of muscular engagement throughout the entire movement. The slow alternating reverse lunge is the final biomechanical alternative to high-impact jumping lunges. Step back and lower your rear knee until it hovers exactly 1 inch above the ground. Hold this position for a full second to eliminate any lingering momentum. During this deep hold, you must monitor the alignment of your front knee relative to your foot. This vector schematic shows the protective tracking limit. The vertical boundary line rises from the ankle. Your kneecap should stop behind this line to ensure the load remains on the muscles rather than the tendons. When you are ready to return, drive the upward movement entirely through the front heel to pull yourself back to a standing posture. Halting the knee's forward momentum against this invisible boundary shields the patellar tendon and forces the glutes to provide the power for the ascent. If these mechanics are followed, you will feel the immediate physiological feedback, heavy oxygen demand, and an elevated heart rate achieved without ballistic velocity. This high cardiovascular output is possible even in the absence of joint pain or skeletal impact stress. These 3 slow-motion sequences provide the technical foundation for executing the full 30-minute fat loss routine. Intelligently re-engineering movement patterns allows for maximum metabolic efficiency while bypassing the joint pain often associated with high-impact training.